Okay, so what we're going to do today is solve a system of equations graphically. So what I need you guys to do is to pause the video, go get your calculator, and come back. Okay, so hopefully you have your calculator in front of you. So what we're going to do is start off by just review graphing a system of linear equations. All right, so when we solve a system of linear equations, we want to type them into our calculator. So I'm going to start with f of x is equal to negative 2x plus 10. So we want to type that into the calculator. Y equals negative 2x plus 10. So you're going to go to y equals on your calculator. You're going to type in negative 2x plus 10. And you need your table of values so that we can plot the points. So type that into your calculator. Put me on pause if you have to. And this is actually not y. This should be your f of x. Remember, f of x is y. So you need some points to plot. Since it's a line, you just need a few points. I'm going to use 0, 10, 1, 8, 2, 6, 3, 4. All right, and you want to plot those points. So I have 0, 10. 1, 8, 2, 6, and 3, 4. So what you could do is use a side of a book, or if you have a ruler available, something straight so that you can make a nice straight line. And since we're going to be graphing another function on the same graph, we need to label this. So this is f of x. All right, now we need to graph g of x, which is x minus 2. So y equals x minus 2. We need an x column. We need a g of x. All right, so you're going to do the same thing. Type it into your calculator, get a table of values. And I'm going to use 0, negative 2, 1, negative 1, 2, 0, 3, 1. And you want to plot those points. 0, negative 2, 1, negative 1, 2, 0, 3, 1. Same thing, use a straight edge to graph. Now, if you use the straight edge, your graph should have crossed right at 4, 2, which was right here. Okay, that's the solution to the system of equations. So you would write the word solution, and you would put the point down, which is 4, 2. Now, this system of equations has one solution. They cross in one spot. So when you have a system of equations and there is one solution, that actually has a special name, and that's called independent. So one solution is called independent. Okay, so we're going to go to number 2. And we'll do the same thing. So we're going to draw a graph. So I'm going to start with f of x is equal to x plus 6. So I'm going to make a table of values, x and f of x. Type it into your calculator, y equals x plus 6. Get a table of values. So I have negative 1, 5, 0, 6, 1, 7, 2, 8. Okay, plot your points. Negative 1, 5, 0, 6, 1, 7, and 2, 8, 2, 8. Okay, use a nice straight edge and connect your points. Make sure you label that f of x. All right, now let's do g of x, which is x minus 4. So we have x and g of x. All right, so type it into your calculator, get your table of values. So I have negative 1, negative 5, 0, negative 4, 1, negative 3, 2, negative 2. Plot the points. So I have negative 1, negative 5, 0, negative 4, 1, -3, and 2, -2. Use a nice straight edge and connect your points. So this is g of x. So notice that my graphs, the graph of my lines, they don't intersect each other. They're actually parallel. And maybe, hopefully, from geometry, remember that when you have the same slope, so my slope of f of x, the slope for f of x, sorry, is equal to 1, and the slope of g of x, that was also equal to 1. And when you have the same slope, the lines are parallel. So there is no solution here. So you're going to write no solution. And the reason why there's no solution is because they're parallel. And when you have a no solution, this also has a special name, and this is called inconsistent. Okay, so let's try the last one, number 3. Okay, so let's start with f of x is equal to 1/2 x minus 4. All right, so type in your calculator. Now, it is a fraction here. See this fraction here? So you can graph the decimals. However, though, it's going to be not as accurate. So what you would want to use are just your points that have integers as y values. So that would be using multiples of 4. So I would use, not multiples of 4, sorry, multiples of 2 because the denominator is 2. So I would use a -4, -2, 0, 2, 2, and 4. That's a 2. All right, so at -4, my y value is -6, and then I have -5, -4, -3, -2. All right, so plot the points. We have -4, -6. -2, -5, 0, -4, 2, -3, and 4, -2. All right, now draw a graph with a nice straight edge, and that is f of x. All right, so now take a look at g of x here. And g of x, that's actually not in the right form. That's actually 4y equals 2x minus 16. So you actually have to put that in y equals form, or g of x equals form. So divide by 4. Make sure you divide everything by 4. So I get y equals, now I have here 2 over 4. Now 2 over 4 reduces to 1/2. So I have 1/2 x, and then minus 4 here. Because -16 over 4 is -4. Now notice that this equation is the same exact equation. G of x and f of x are the same exact thing. They are the same exact equation. So these are the same, x, g of x, these are the same. So that means that graph lies right on top of the other graph. So what's the solution? Well, there's actually, so this is also g of x, so there's actually an infinite amount of solutions. So the solutions are where it crosses each other. They actually cross each other in an infinite amount of spots. So we would write here, the solution is an infinite solution. And this has, because it's the same line. Okay, you can tell when you have the same line because one is a multiple of the other. And this has a special name, and this is called dependent. All right, so we had, remember, one solution. That was the first one. That's called independent. We had parallel lines, which was no solution. That's called independent. And then the last one we just did here, which one line lies right on top of the other one, which is an infinite amount of solutions. That is called dependent. All right, so now we're going to start graphing some linears and quadratics. All right, so I'm going to change pages here. Okay, so to solve a system of equations graphically, the first thing you want to do is you want to put them both in y equals form so that you can graph them on your calculator. So you're going to plug it into the calculator, make a table of values. The reason why we make a table of values is because this is our work for the graph. You're going to graph both of them on the graph paper. I would like you guys to circle the solution and then use your calculator to find the points of intersection. All right, so to find the points of intersection, you're going to write it right over here on the side. You're going to do second calc, and you're going to do intersect. Okay, and they'll say first graph, second graph, just hit enter, enter, and they want it to guess, so hit enter. All right, and then write your solution as a point. So let's take a look at this one right here. F of x is equal to x squared minus 6x plus 5. So you can put me on pause and type it into your calculator so that you can get your table of values. So this is a parabola, so we can't just pick any old points that we want like we did with our line. You actually have to find the turning point. So find that middle point where above and below that middle point is the same. That was at 3, negative 4. And then I have 2, negative 3, 1, 0, and 0, 5. And then I have 4, negative 3, 5, 0, 6, 5. And remember, when you have a parabola, I have this turning point, and then the numbers above and below are the same. All right, so plot your points. So I have 0, 5, 1, 0, 2, negative 3, 3, negative 4, and so on. Just plot your points. Graph your parabola. Okay, so just label that f of x. All right, now we're going to graph the linear. So notice that this is not in y equals form, so I'm going to write it right up here. Y plus 7 is equal to 2x, so minus 7. So remember, this is actually g of x. G of x is actually equal to 2x minus 7. All right, so you could put me on pause so that you could get your table of values. All right, for g of x. All right, so I have 0 is negative 7, 1 is negative 5, 2 is negative 3, 3 is negative 1, 4 is 1, 5 is 3, and 6 is 5. So you can already see we have one of our solutions right here. We have the 6, 5, 6, 5 there. And the other solution is right here because they're the same. Okay, but I want you to graph it so that I can tell you how to get it on your graphing calculator too. So plot the points. So we have 0, negative 7, 1, negative 5, and so on. So just plot your points. Okay, use a straight edge to connect them. Okay, make sure you label that g of x. All right, so my solutions are where they cross each other. So my solutions are, and I'm going to tell you in a minute how to get it on your calculator, 2, negative 3, and 6, 5. Okay, so now on your graphing calculator. So you should have both these equations graphed on your graphing calculator. So now what you're going to hit second calc. That's the trace button. And we want number 5 where it says intersect. Now, what it says on your calculator says first curve. So what I'm going to do is I'm going to find this point right here first. All right, so for me, my cursor is blinking right above here, right about there. So move the cursor closer to the point. It doesn't have to be right on the point, but it has to be pretty close to it so the calculator knows which point it's actually trying to find. Hit enter. It says second curve. The calculator will automatically jump to the other curve, which for me is my line. So just hit enter. And then it says guess, and you want the calculator to guess that point. And you should get to negative 3. Okay, that one right there. All right, so now we're going to find this point right here, the second point. All right, so hit second calc, number 5, intersect. Now, my cursor is right down here on this point, so I have to bring it up here closer to the other point I'm trying to find. And again, it doesn't have to be on the point. It just has to be really close to the point. So hit enter. It automatically jumps to the second curve, so hit enter. And then you want it to guess, so hit enter. And you should get 6, 5 as that other point. All right, so the next thing we're going to do is do a linear circle. All right, so let me just move my page down. Okay, so let's actually start with the linear, which is the g of x. All right, so type it into your calculator, get your table of values. All right, so my table of values would be 0, -3, 1, -1, 2, 1, 3, 3, 4, 5, and 5, 7. Plot your points. Okay, use a nice straight edge to graph your points. Plot your points there and call that g of x. All right, so now what we want to do is we want to graph your circle here, right? This is your circle. All right, so the center of the circle is 0, 0. And remember, this is your r squared, so we want r just for radius. So that's the square root of 36, which is 6. So here's my center at 0, 0. My radius is 6, so count up 6. Make a little line, down 6, to the right 6, and to the left 6. All right, and just try to draw the best circle that you can. Okay, so now it looks like it's going through this point, but I don't know if it actually is. And they could be off, they could be decimals, I'm not really sure. So I'm going to now tell you how to graph a circle in your calculator. So you have to take your circle, x squared plus y squared equals 36, and you have to put in y equals form. So you're going to minus x squared. So you get y squared is equal to 36 minus x squared. Now take the square root of both sides. Remember, when you take the square root of both sides, you get plus minus. So it's plus minus the square root of 36 minus x squared. So you have two y values. Y is equal to the square root of 36 minus x squared. And y is equal to negative the square root of 36 minus x squared. All right, so you can type them both into your calculator. So they should be in your y2 and your y3, because in your y1, you should already have your line in there. So that, remember, your linear was 2x minus 3. All right, so now in y2, put in the square root. So typing in the square root of 36 minus x squared. And then in y sub 3, type in negative. Make sure you put the negative first. The square root of 36 minus x squared. All right, now hit graph. So you'll see your line first, and then you're going to get the top part of your circle, the bottom part of your circle. Now it's going to look like an egg. And the reason why it looks like an egg is because your calculator screen is in the shape of a rectangle, not a square. So if you actually hit zoom, number 5, which says z squared, it'll square it out and it'll actually look like a circle. All right, so do that right now. All right, the only thing is that it kind of doesn't connect in the middle, but it does. It now actually looks like a circle. All right, so now let's actually find those points. So hit second calc. I'm going to find this point first. And the reason why I'm going to find this point first is because the top part of my circle is what I typed in first. That's this one. This is the one that I plugged into y sub 2. The line was in my y sub 1. So whatever you plugged into y sub 1 and y sub 2, that's what you have to work with. If you plugged in this one, which is my y sub 3, if you plug that into y sub 2, then you have to find the other point first. All right, so do second calc, number 5. My cursor was down here. So I'm moving it closer to that point. Again, it doesn't have to be on the point. It just has to be really close to it. Hit enter, enter again, and you want it to guess. And for me, you can round the points to the nearest hundredth. That's 2 decimal places. So that point is 3.82, comma 4.63. All right, so that's this point right here. Okay, now I'm going to look for this point. Now, to find this second point down here, you actually have to go back into y equals, take out y sub 3, and put this equation, the bottom part of your circle, into y sub 2, because your calculator doesn't know to go to the third equation in your y equals. It only knows to go y1 and y2. So you have to change your y2 to your bottom part of the circle. Okay? So what you'll actually see is just the bottom part of your circle now. All right, so do second calc, number 5. All right, bring it closer to the curve, to the point. Sorry, hit enter, enter, and you want it to guess. And I get negative 1.42 and comma negative 5.83. Okay, so those are your solutions. And I know the circles can be a little tricky, so we'll practice more of them in class tomorrow. All right, have a good night, everyone.